Okay, so I more or less cleaned off the chassis of the Philips BX230U, and well, one of the first things I noticed is that the cable which would turn the needle of the tuner, well, the dial needle rather, which would slide it back and forth behind the dial plate or the faceplate of the radio, is broken. As you can see, there's a cable, well, a small cord, broken cord, flopping around here. And there's also this. Now apparently, I don't know why exactly, they ran, whoop, yeah, there are some small parts. They ran the cord through a flexible copper spring-like tube which has two brass endings. I'm trying to put it together again with one hand. Hang on. Come on, come on, come on. Yeah, there you go. So, and this fine brass thing was placed like this inside little openings which you see there on that metal holder. Yeah. So, and the brass spring-like guider, rope guider, went all the way up to here like this. Well, I don't know whether it was in the first opening or in the second opening, but my guess is, watching the tracks on the wheel, on the dial wheel, that it must probably have been the first hole. Now, the fact that there is a second hole might mean that there must have been, at a certain point in the past, exactly the same kind of rope guide here, but I couldn't find any, and I didn't find any, and well, to my infinite regret, it must be gone. It must be lost. So I'll have to find an alternative, possibly to guide the wire around the wheel. In my opinion, and I think I already said it, this whole dial thing is over-engineered, in my opinion, and completely unnecessarily complicated. But okay, I mean, that too is a little bit typical for Philips. Philips always has had, and probably still has, the tendency of over-complicating things for some mysterious engineering reason. Also, I also noticed, and I hadn't noticed it before, this wire here flopping around rather uselessly, and if you look underneath, you see there's a big knot in that green wire up there, and I have no idea what the wire is for, so I will most probably have to look it up on the schematic and try to find out what it does or what it did. Then I failed to mention previously that there is, in fact, in this radio, an electrolytic can. In fact, the can contains two electrolytic capacitors. To be more precise, two electrolytics of 50 microfarad, and they seem to be rated for a voltage anywhere between 250 and 280 volts. So I guess I will have to replace those electrolytics too. So that will cause me a little bit of a hassle, because this electrolytic, instead of just being say clamped or anything, is attached with a bolt, a large bolt, which you see down there under the chassis. So I will have to undo that too. Now, I did notice on the schematic that the radio uses a rectifier bridge. Now, and I mean by rectifier bridge, I mean a solid state rectifier bridge, apparently. At least I think it does. I don't have the schematic handy, but if I remember correctly, there should be a rectifier bridge somewhere. Now, I could be wrong, of course. Anyway, if there is a rectifier bridge, I can't find it for the moment. I racked my brain what it could be, but all I can find inside the chassis are capacitors and resistors. But I see no trace of a solid state rectifier, or even loose germanium diodes or stuff like that. No trace of that. So I could be wrong. Anyway, I'll look it up and I'll tell you about that part of the power supply in a next update. Also, you can see there are quite a few IF cans. And there's one here, there's one there, and there are two more there. And of course the obligatory tuning capacitor. There is a power resistor, as you can see here there, with several tabs. Now, again, I have to check on the schematic, but it's interesting to see a power resistor built like this. It's glazed, so it's a sort of a ceramic resistor, which, well, is kind of interesting to see. You don't see those very often. Also, there is a resistor, a power resistor in parallel with two of the tabs on the power resistor. It might be original, it might be a later addition. That too I'll have to check on the schematic. And then there is this. This is the audio output transformer. Now, I didn't measure it yet, so I thought that maybe we would enjoy measuring it together. So let me prepare my multimeter and a few crocodile clamps. Hang on. Okay, there we go. So the output of the speaker was, or rather the output towards the speaker, are these two tabs here. The input of the audio transformer or the inputs are there. There are three tabs there. So actually what I want to investigate right now is continuity. I'm not too concerned yet about possible value discrepancies and all that. All I want to do is see whether the coils of the transformer are still good, because if they are not, then we have a problem. Okay, let me switch on my tester and let's put it on to say 20 kilo ohms. Okay, so let us test the first contact. Okay. Okay, there seems to be conductivity. I think that means about 1 point. It's still dropping. Well, the meter is fluctuating, so I would say the secondary of the audio transformer. Hang on, it's still dropping. Okay, anywhere between 800 ohms and 1 kilo ohm. You see, it's still dropping. That's peculiar. I don't know why it is dropping. Anyway, there is continuity. The reason why it is dropping might be because there is somewhere a capacitor or something in the circuit. Okay, now let's test if there is a short circuit between the secondary and the primary. Oh dear, and there seems to be... Yeah, maybe not. Let's see.
The king stops breathing. The king turns blue in the face.
Phew.
And you can imagine
it keeps fluctuating. Now it even shows a negative value. That might be a capacitor discharging. Okay, here. Okay, and now there. Okay, but what I do notice is... Okay, let me measure it rather this way.
Edward VII expected the ceremony to be delivered absolutely perfectly. He watched every detail of it with care.
Minus 7 mega ohms. That's peculiar. I don't know what it means. Maybe the battery is empty of my multimeter. That could be it too. Although I'm pretty confident the meter works. So, okay, between the secondary and the primary of the audio transformer, there seems to be something going on. But again, I have to take a look at the schematic to see whether what could possibly influence the reading. Okay, let's see now for the primary. Okay, 0. Okay, wait, hang on.
Determined to bring light into his mother's fusty apartments, he hired technicians to install electric lights and theatre designers to transform Buckingham Palace.
Okay, it fluctuates, but well, I would tend to say the resistance is somewhere in the range of 400 to 500 ohms, which seems to be pretty much okay to me for a primary of an audio transformer. One side of the coil registers around 90 ohms, and the other side
Edward VII realized that on its own, the restoration
registers 450 ohms. Yeah. Okay. Fine. So the total should be around 500 and a bit. But like I said, it keeps fluctuating. So maybe it's a bad contact. In any case, I would tend to say that the value of the primary and the value of the secondary of the transformer are more or less within acceptable limits. Probably the measurements are fluctuating because the contacts are really very dirty. Okay, now another interesting detail about this little radio is this switch you see here. Now, hang on.
All the aristocracy and the Tory party, because he was highly critical of privilege and was very vociferous about saying so. And Edward VII meets Keir Hardie, and he
This is the front panel of the radio, and as you can see, on the left side there are two symbols. One is for the low tones, one is for the high tones. So what the switch in fact does is to switch between low and high pass. In other words, you would either let through the low tonalities, so cutting off the high frequencies, or vice versa. Now, again, this is typically Philips. They built a, like you see here, a rather interesting little tumble switch, tumble activated switch. You know, this little fork here pushes against one or other spring, and that in turn activates a rotary wafer with tiny little electrical contacts you see there, and thus it makes contact either with, I suspect, a capacitor of one value in this position, or a capacitor with another value. Actually, maybe, you see, this contact goes to ground. As you can see, the wire here is soldered to the ground over there, to a ground lug. So it could be that a certain frequency range is short-circuited to ground. If you switch it over in the other position, and that's a bit hard, yeah, then it probably makes contact with a capacitor down deep in the chassis. Or one other possibility is that there are two capacitors down here somewhere in the chassis, and either one is connected through to mass, thus filtering a part of the sound frequencies. It's a good possibility that is what it is, but there too I have to check on the schematic. Alright, then, well, this is the switch. Actually, this part of the switch, to switch between low and high frequency. I'm not going to slide it back onto the shaft because the shaft is too dirty. I need to clean it. But anyway, you can see a small fork-like protrusion here up above on the button, and that fits exactly within this fork here. Let me take my pointer. So you have a fork-like indentation here. So by moving this switch either this way or that way, you switch between two tonalities, as the front panel indicates. Also, this receiver receives certain frequencies. I would tend to say short frequencies, AM or medium wave frequencies, and long wave frequencies. And as you can see by the little icons on the front panel, you see here this position, that position, that position, or pickup position. So in effect, there is another button, which is this one. You see, with a I forgot the word for it, but with yes, a gear molded into the bakelite. And if you put it in there, you see, like that, then you could easily switch between each position. Yeah. Actually, the weird thing is there are only 3 positions here, whereas the front panel, as you can see over there, indicates there are 1, 2, 3, 4 positions. So that is a bit of a mystery. I'll have to investigate what it means. Now, again, this too is typically Philips. Watch here. You see here a small ball bearing, and the ball bearing here presses onto this specially formed shape of this gear, and the gear is connected to a rotary switch inside the chassis. Now you see these little notches here, one here, one here, one here. So there are in fact 4 notches. Maybe I'm being a little bit too brutal switching them. Let's see. Okay, so the first one was position 1, then position 2, then position 3, then position 4. Okay, no problem. We have 4 positions. But the spring action with this little ball bearing here is not very fluid, so I will need to clean it with some WD-40 or something like that. Anyway, this sets the switch in 4 positions and holds it in each of the positions, thanks to this gear knob you see here. But that too is a little bit overcomplicated, but okay, it's Philips, so that's one of its idiosyncrasies. Okay, so what's the plan? Well, as you can see, there are quite a few things I need to do. I need to find a way to repair the tuning cable, which has broken, as you can see here. I might even have to find something to replace the lost guide rope guide you see here. Maybe I can use a little end of plastic tubing, rigid plastic tubing. That might work, but we'll see. I don't know yet. Then there's the mysterious floppy cable here. You know, it was soldered to something, obviously, but now it just hangs loose. So I'll have to find out where that came from. Then I need to unmount the electrolytic capacitor can you see here, this one, and replace the electrolytics inside with two new ones. And then comes the part where I must check one by one the resistors underneath the chassis and change the resistors that are beyond their prescribed limit. And in any case, I will replace these paper caps, these black tar caps for sure, and maybe this mica cap too. I don't know yet, but we'll see. I'll make some measurements and I'll try to figure out what needs really changing and what doesn't. Of course, I don't know whether the tubes are still good, but the problem is it's a special kind of tube and my tube tester can't test those with that kind of socket. So probably the only thing I'll be able to test is continuity of the filament with my multimeter, and that's about it. So yeah, there's quite a bit to do, but I'm confident we can do it in not too much time. And anyway, like I wrote in my previous update on future projects, I really don't have that much time right now to spend on restoring stuff. So this will be something I'll be doing on and off in between stages I work on the house. So stay tuned, and I hope you enjoyed this view of the Philips BX230U. Oh, hang on. And this is the case of the radio. Hang on. Well, there you go. This is the case of the radio. Nice, huh? It has, I don't know if you can see it, but it has a nice brown sheen on top and on the sides. It's really a nice radio. Of course there are a few scratches and all that, but I buffed most of it out because you see the owner didn't ask for a complete restoration, but only to restore, well, to clean thoroughly the outsides of it, and if possible restore the radio to working normally. Also, I'm beginning to suspect that maybe someone did actually try to disassemble the radio, because if you look here in the corner, you see one of the studs to which the chassis was attached has broken off. If you look in the other corner, you see how it must have looked like, and this is how it looks now. Also, the chassis was not attached to anything inside the cabinet. It just was kept inside with the knobs and the back mounted on the radio, and that's it. So the chassis could sort of flop around on its own. So well, I might have to find a solution for that too. Okay, well, that's really it. So thanks again for watching, and stay tuned for another update on the Philips BX230U.